Hi students, welcome back. In this part, we are going to study about the tangents and the normals, the two most important lines with respect to parabola. And again, you will see this in this part, very key points, they will be highlighted. You will be studying different forms of tangents, normals, and again, important tips will also be given. So please study it very carefully and practice lots of questions based on this topic. You can pick from last year's question and you will see the concept of tangent and normal, it's always there when the questions from the conics it comes. So let's begin with the part. So equation of tangent in various forms is given as below, and we will study about the normal also. So let's see first that how do we get the tangents, okay, then we will talk about the various forms. So now if this is my curve, okay, and if this is a tangent, okay, let me draw it using another color. Yeah, so tangent is the line which is cutting or touching the parabola at one point. Now if I join it, okay, so this one is the point where if I say x1 comma y1 is the point where the line is touching the parabola. So this line becomes the tangent. So we have the point, and slope we can get from the equation of parabola or any curve. So if we are having, suppose in this case, parabola, so slope of this curve at a point x1 y1 will be given by differentiating with respect to x, that will be 2y dy by dx equal to 4a. Now dy by dx at a point x1 y1 will be 2a by y1. When you bring it here, so this is the slope and you have the point, okay. So now we know we can find the equation of line using the simple point form, point slope form. So in this you can substitute m by this value, and y1 we can substitute from the parabola. The y1 square will be equal to 4ax1. So let's see that whether we can make that use of that thing. So this will be 2a by y1 x minus x1, cross multiplying it here, y1 equal to 2ax and y square will be plus here y1 square. So we are getting y1 square, we can use it directly, and 4ax1 we will take 2a common, so x minus x1, and from here 2a if I take common I will be left with 2x1. So this gives me our first form, which is the basic form, the point form, that if the point is given, straight away what we need to do. Now this is, I can do it generalized. So this also we will later come to know that this is known as t is equal to 0. Now t represents the tangent, and what do we mean by that? So see, in any second degree curve we will have four things, x square, x term, y square and y, or if you remember, we write it at 2gx 2fy, okay, so 2x and 2y. So what you have to do, write this as x1, this as x plus x, y as y into y, and this will be y plus y. Now I have written the equivalent form, and if I am looking at a point, just make one of these things as this thing. So if you apply this conversion on any curve, that you make x square to xx1, 2x to x plus x1, y square to yy1 and 2y to this. So you will get an equation of tangent at a point, and this conversion is known as like we represent it by using t equal to 0. So in t equal to 0, what do I mean? I'll write it like this. So anywhere if I am writing t is equal to 0 means I am referring to this equation, that converting the variables and transforming them in the equation of line from a curve, okay. So this is a very popular conversion. Now looking at the slope form, we have already done this in the previous session, that the condition of tangency was c is equal to a by m. So slope form, any line in the slope form will be, slope intercept form will be like this, and this condition we have already derived. A parametric form now. So this is very important, as I mentioned when we have studied this thing. So in parameters, if you remember, the
points on the curve were nothing but 80 square and 280. Okay, so now instead of replacing here in this equation only, if I put these parameters, I'll get the desired condition. So this will be y into 280, this will be 2a and x plus 80 square. Now remember, this is a general point. If I am talking a specific, I'll substitute here t1 and 2a will get cancelled and y t1 will be 2x plus 8t1 square, or 2a will not be there, so 2 will be cancelled, so x plus, so this is the equation of tangent in parametric form. Now what do I mean by parameter? So this t1 is at a particular point. Now if we generalize it, we will end up to this thing. Okay, so now this was about the tangent. Now any line which is perpendicular to the tangent as shown here, that the normal is the line. So once we are knowing the tangent, what we have studied, that for the, if we are having two lines having slope m1 m2, if we know this and these two are perpendicular, the condition is m1 m2 equal to -1. So by deriving the equation of tangent, we can find the slope, and from that we can find the slope of the normal, and then we can find the equation of normal using again this form. In this case only thing changes m1, and that will be minus of this reciprocal of this, so that will be minus y upon 2a1. We will study that also. So let's see, study some facts, okay, about tangent and normal. And again I'll say this is one of the most important part of this whole chapter, the tangents, okay, tangents and the normals. So it says, now talking about more about the tangents, so we have studied that we are having 3 points with respect to a parabola on the inside. So inside we cannot have a line or line such that it touches the parabola, means it has to pass through 2 points, or it won't be touching, it won't be intersecting, means even if you draw a line parallel to this, it won't be touching. By touching we mean that the point should be on the parabola. In this, if you are looking the point inside, okay, so we can only draw a line parallel which is not actually a tangent. On the parabola, we can find that one line passing to the point which is point of contact, it becomes tangent. From external points, now let us see what happens. So from external point, as shown here, if this is an external point, we can always draw two tangents. Okay, so now let us see that how is that possible, looking at the equation of the tangent. Now in slope form we can do it using any form, but in slope form, as we know that this is the equation of tangent. This is the equation of tangent, any general tangent. I have not specified y1, x1 or anything. Okay, so m1 can be known with respect to the curve at a given point. So with this, what I mean to say is that this is a general equation. Now if we solve it, and we know that if from external point, if it passes through, so we can write this as y1 equal to mx1. Now from this, the only variable which is there is m, because a will be known from the parabola only, and since we are not knowing the point on the parabola where it passes, we are looking at the point external, so we do not know this m also, that we have to determine in this case. So once we do it, it becomes a quadratic in m. Now what does that mean? A quadratic in m means we will have two slopes. So one will be corresponding to this line and other will be corresponding to this line, the second line. Okay, so clearly this is the condition of having tangents, at most two tangents from external point. Okay, now we will see that how the condition comes. So now again we will find the d for this equation. So d for this equation will be m square minus 4a, not m square, this will be y1 square, because we are looking with respect to m here only. So y1 square minus 4a x1. Now this is the d. Now if I put d equal to 0, now this is something related to the parabola. the original parabola, this one. So this means that this point is actually lying on the parabola, and since we have only one root, this satisfies the condition that from point on a parabola only one tangent can be drawn. Now if d is greater than 0, we will have y1 square is greater than, so this was the condition when we said that the point lies exterior to the parabola, if you remember. So now it means for d greater than 0, this is the condition, and what does this implies? It means we will have two roots m1 m2. It means we will have, if this was my equation of tangent, so I will have two tangents. One will be y equal to m1x plus am by m1, and another will be y equal to m2x plus a by m2. Again from this we will derive lot of conditions. Okay, so let's see the next slide. Now it says point of intersection of two tangents. Okay, again a very good important topic within the tangents. So if this is the parabola, and if you are saying that 2 points which are like tangents, from which tangents are drawn, we are not saying in the earlier case we were saying a point is there, we are drawing two tangents. Now what we are saying, let 2 points on the parabola be there, and we are saying interested in finding this point. Okay, so from this what we can do, we can let 2 points here in the parametric form. Again we can go by the slope form or like normal parameters, but you will find it more difficult to solve it, because here only we are having two variables. Now if you solve it using x1 comma y1 and x2 comma y2, you will have four variables which will be difficult to handle. Now from both these we know the equations of tangent. So the equation of tangents from this point will be, if you remember, this was x plus at1 square. From here it will be y(t2) equal to x plus at2 square. Now on solving this, we will get, now all of us can solve for x and y. What we need to do, subtract this, you will get y, put any in one equation, you will get the corresponding x from there. Okay, so clearly when you will solve, you will get the coordinates like this. Okay, so on closely looking at the coordinates, can I say the x coordinate is nothing but the geometric mean of the two? If I take the geometric mean, I will end up in having t1 t2, and this one is nothing but arithmetic mean. If you add these two and take the arithmetic mean, so this is the way we can remember. Now the crucial point here is that we are learning here that we are seeing a point with respect to two lines, and we are, in the earlier case we were seeing two lines with respect to a point. So again these conditions will be very helpful when we will be doing questions based on this, and on the test paper you will see some advanced question based on this, the parametric form, tangents and normals. So you have to be very like comfortable in this topic. Practice it again, try to understand what is happening. We are seeing a line, we are seeing a curve, and we are trying to solve it by putting the condition d equal to 0, and we know that with respect to this point we can write it in terms of parameter. So that parameter is known as t, and then we are putting according to that parameter the final equation of line. So that is again very useful. So moving on to the next thing, normals. Okay, so we have discussed major things about the tangents. Now again to the normal, we will be seeing similar things, three things, and that conditions are again derived from the tangent. So for this, if you remember, this was y1 equal to 2a into x plus x1. So if I compare it with this equation, now we know that the equation of line is y equal to mx plus c. So from comparing it from that equation, we can clearly see m is clearly 2a by y1. Now as I have mentioned that the condition for perpendicular lines is m1 m2 equal to -1. So if the slope is 2a by y1, So clearly for normal it will be reciprocal of this thing and minus sign. So just I've substituted that. Again slope form from, you can again derive that. What you need to do, y minus y1 and put the slope as here y1 by 2a, and this will be x minus x1. Now same thing you are going to do in this also. Substitute the various variables y1 in terms of using from the parabola. You will end up in this, getting this equation, again a very useful equation. So remember the equations of normal. From here we will see that we are having, if I say this is a general equation of normal, so from this if I put a point x1 y1, okay, so now here you can see it is a cubic in M. Interesting point to note. So this is something you will see as co-normal points. Topic which is related under this. So basically from a point you can draw three normals to a curve, okay. So that point is definitely, so again we will need to check the condition for that point, that whether it is inside on side or outside or on the parabola. So again we will have different conditions for that, okay. We will again do questions based on this in the later part. So we will see, you will find it very useful. This one again similar way, instead of putting y1 here you can just substitute the parametric form which is right here, okay. So again you can derive these things using the equation of tangents. You have to remember parametric slope form for sure. This we can derive anytime. This you can derive, but it's better if you remember, it will save some time. And this is again very two important points to remember, okay. So what this says, if a normal at a point T1 meets the parabola, again if I am saying that this is a tangent and if I am drawing the normal, it will definitely intersect it again. So if this is intersecting the parabola again, so for that this is the coordinate, means if this is T1, so this you can write it as minus T1 minus 2 by T1. So again very important result. What you can do, you can solve this equation with the parabola y square equal to 4ax and you will get this condition, okay. Again a very useful result. And this one again not as that important, but you can remember it for your reference, okay. So this is again lot of ways to remember this. So again very important topic as far as the JEE is concerned. We'll discuss a lot of questions in the next presentation part. We will do exclusively questions based on this, and in the test paper also we will have a lot of questions based on JEE on this concept. So this is for your reference that we have done regarding to this, the three equations, okay. And you can see similarly for other three cases, you can read it, and majorly this will be of more importance, but at times this will be very helpful, these three will be. So if you know this, you can figure out that how to do it for the other three cases.
So I hope that you have watched this part very carefully and you will be practicing lots of questions based on this. Also in the next part we are going to discuss the questions based on the concepts which we have learned, and again mentioning it again, these will be basics for the starting. Advanced questions that will be discussed in the test paper solutions, okay. So stay tuned for the next part.